have.
Yes.
Thank you.
Okay, let's go down to the Kennedy Space Center now for questions.
Yes, this is Marcia Dunn of the Associated Press. For the Japanese director, I was wondering how long is the Japanese module arm when it is fully open, and how big is the Japanese airlock?
How long is the arm when it's extended?
Okay, the length of the arm is almost 10 meters, 9.9 meters or so for the main arm. But I'm not sure when actually fully open. It's not during this flight, I think. It's okay.
In the size of the airlock, please.
I'm sorry that I.
Marshall, we'll get you the exact dimensions of that.
Thank you very much. And for Mr. Rodrigues, you've worked so long with this module. I'm just wondering if you could sort of say in your own words how impressive, how cool is this gigantic piece of hardware with all its bells and whistles?
It truly is amazing. One of the reasons why I've taken a liking to this segment is its multi-capability. I mean, it really is an amazing design. Having the airlock as part of the element, having the exposed facility, the robotic arm. The Japanese engineers have done an amazing job putting this module together, and I can't say enough how impressed I am with their talent and dedication in putting this together. This is why I really stuck with it so long, is because it truly is a beautiful piece of work.
Thank you. And finally, one more question for the Japanese director. Are there any mementos or items that are traveling into orbit with Kibo to commemorate its this historic occasion from Japan? Any national heirlooms?
Okay. The first moment for Japanese and the JAXA's people was a great moment is when Japan's first Kibo logistics module installed on ISS during that flight, and also first ingress by Japanese astronaut Takao Doi and Peggy Son inside the JLP. But this flight is a second step for JAXA, and the most important time for this flight should be also installation of the module into the harmony and first ingress. Then when we successfully activated the module during this flight, that may be the most important and comparable time for us.
Okay, now to NASA headquarters for questions.
Thank you. Tracy Watson with USA Today with several questions for Mr. Yamamoto. When do you expect full utilization of Kibo, all of its scientific facilities being used, and how large a crew will that require?
For the external payload? Okay, the first opportunity for us to bring the external payloads is on the flight 2JA. We plan to bring two exposed payloads. That we plan next year. What's the second question?
Yeah, how large of a crew will we have inside the module to work on all those systems?
Okay. I think that for the crew size, we don't expect so many, large number of crew to operate our external platform and the payloads. But we really need the crew time for utilization. So 6 persons crew is preferable, but less number of crew can operate that.
That's right. The module is actually designed to hold 2 crew members in it for operations, but obviously can contain more crew members as necessary to complete the objectives.
Okay, thank you. And to clarify, when will all the science racks in Kibo be used? When will you be able to use all of them at the same time? How many years from now?
I don't have an exact number for when a year, because the current plan expects almost half of the experimental racks occupied in the pressure module in a couple of years. We need additional transportation capability, including the Japanese HTV. It takes more than a year.
Okay, thank you. And finally, the last question. How much will you get out of Kibo if the U.S., if NASA ends its participation in the ISS in 2015?
I think the concern is if we end the station program in 2015, is there a concern with the JAXA team regarding how much benefit we can get from the Kibo system?
Okay. JAXA's module designed for lifetime for more than 10 years. That means can be operated until 2016 and beyond. But our current program does not define beyond 2016. So maybe we can talk with NASA and international partners the possibility for a potential extension. But I don't know the detail yet.
Okay, that's it from headquarters. We're back here in Houston for follow-ups. Mark?
Mark Carreau from the Houston Chronicle, and I'm wondering if you can sort of explain the early history and thinking of why the Japanese lab is as large as it is. It seems incredibly large, and somebody must have thought that was a good idea in the beginning, and I sort of wondered, for you guys that were involved in the early going, how that came about. And also, if you could talk about the research plan for the module as it exists now in terms of whether it's planned to be more fundamental research in sort of physics and biology, or there's a desire to do something more applied, or a combination.
I could take that first part. Back in the Space Station Freedom program, each of the international partners were given certain requirements to design their modules, their laboratory modules to fly. And I know that the Japanese team, the NASDA program, did want to maximize their capabilities, which is why they ended up designing the module to as large as they could, thereby giving it as much capability as possible, and also adding the additional flight at the time to bring up the exposed facility and the logistics carrier. As far as the uses of the payload operations, I'm not as familiar with that. I don't know if Yamamoto-san, if you're as familiar with that or not.
Okay, for the payload operation, we have several racks for life science and material science, and also we have other equipment for image processing and TV camera. And utilizing that, we also plan to perform some educational project, or a more culture project like that. So we want to extend to the possibility of the capability of our module as far as possible.
Is that it, Mark? Over here, Jim.
Jim Ober with NBC. To follow up again on the Japanese science